Realistically speaking, injection attacks against APIs are not that different from traditional applications. However, unprotected APIs are often exposed when they shouldn't be, and the defense in depth principle is not always adhered to. So we can often find APIs with injection vulnerabilities present. Also, we should consider that NoSQL is becoming increasingly popular, and therefore we need to be able to not just find and exploit traditional SQL injection vulnerabilities, but also NoSQL injection vulnerabilities as well. We'll look at how to fuzz for these vulnerabilities in APIs and how to exploit them. This will give you a methodology to start using going forward. However, I strongly recommend that you continue your learning journey after the course, as there's always more to learn. Oh, and we'll be taking a quick look at getting up and running with the popular tool SQL Map as well. After this section, we'll be entering the mid-course capstone, so this will let you test what you've learned so far in the course and give you a chance to start dialing in your methodology. I recommend you treat this like a real-world engagement to get the most out of the exercise. Let's dive into our injection module. Before I give you a live demo and a challenge, let's walk through some theory of traditional SQL injection. In a nutshell, SQL injection lets us manipulate or change SQL queries that are made to a database. For example, if we have a simple SQL statement, our input might change it so that it returns a different result. Here we have select all from messages, where sender equals the username. So in our case, if our username is Jeremy, we have select all from messages, where sender equals Jeremy. So this will return all of the messages where Jeremy is the sender. If we change this, if we can inject our own value into the username parameter, we might get something like select all from messages where sender equals Jeremy or sender equals admin. And of course, this will return all of the messages where the sender is Jeremy or the sender is the administrator. Fundamentally, it's really that simple. The situation becomes more complex when we have things like input filtering that we need to bypass. In this case, we can't simply assume our input is being directly appended to the SQL query. Different databases also have slightly different syntaxes, so enumerating the underlying technology is also part of our process. Sometimes a query will trigger an action that is not visible to us, so we're unsure whether it actually worked or not. This is called blind SQL injection. But don't worry, as long as we have solid fundamentals, take the time to understand what we see in practice, we'll be successful. In this module, we're going to look at a few common ways to find and exploit SQL injection. We'll cover fuzzing for SQL injection, triggering error messages, verifying our SQL injection attack, using a union select attack to steal data from other tables. We'll then look at the logic of a common authentication bypass, and then of course we'll also look at NoSQL injection too. I'll see you in the next video. Alright, so let's dive in. I'm here in my labs folder and we have the API injection.zip. So I'm just going to unzip API injection.zip, hit enter, and then you'll see that it created a API injection folder. So, whoops, we'll just come into this and have a look, and then we'll just sudo docker compose up. And this should build the image for us if it's not already built, and it will spin up our challenge. And then we come to localhost, turn off our proxy, and we have our lab. And you can see you might get this message saying test data inserted successfully. This is just the initial populating the database with some products and some users and things like that. So when you refresh again, that should disappear. It's just a little script that I added so that we didn't have to manually set up the database. So first thing I want to do is I'm going to open up Burp Suite, and we're going to do this two ways again. We're going to fuzz for SQL injection using Burp Suite first so that I can show you. And you can do this on the community edition as well. Just know that it's going to be rate limited, so it's going to be a little bit slower. And then we'll do the same thing with another tool as well. So what I'm going to do is when we come to our SQL injection demo, get coffee by roast level, I'm going to follow what I usually follow on any web application assessment, which is I'm going to test the functionality. Usually when I come to a web application, I'll go in and I'll step through everything. I'll send messages, I'll log in, I'll create users, multiple users, and I'll make sure that I understand how the website functions and what it's meant to do, what normal behavior looks like. In this case, we're just going to test this, and we press 3 or enter 3, and we get a coffee back. So the coffee ID is 5, the origin is Guatemala, and the roast level is 3. And we can check for other roast levels as well. So 4, we don't get anything back. 5, we get 2, so some Ethiopian coffee and some coffee from Indonesia as well. So I'm just going to switch on my proxy, and then we're going to just send this request again so that we capture it. Come back to here, proxy, HTTP history, and we can see the request in Burp Suite. So there's 2 ways we can do this. One is manual testing, and the second is fuzzing. So what I'm going to do is I'm going to fuzz first. So I'm going to press Control-I, and you can see that I've sent it to intruder, or you can right-click, send to intruder. And then you can see that it automatically detects where I want to put my payload, which is good. I'm going to use the sniper, come to payloads, and then we have a choice of lists. Now, word lists are a personal preference. I definitely recommend testing out different word lists, see what has good results for you, see where their shortcomings are, and even develop your own. So concatenate some word lists together, make some shorter if you think they're too long, and things like this. So we have a few built into Burp Suite already. So we have fuzzing, quick, full, usernames, passwords. And what we want to do is we want to scroll down and we want to come to SQL injection. So you can see that there are a bunch of basic SQL injection payloads here as well. And all I'm going to do is hit Start Attack. And obviously we're running locally, so it's very, very quick. And if you're on the Community Edition, this will take some time. And the fact that we're getting all sorts of different lengths in the response, and we're getting some different response codes, so we're getting 401 and 200s, this is an indication that we do indeed have some SQL injection vulnerability. So if we have a look at the response here, we get unauthorized, no coffee found. And if we keep going down, we get, this is just a blank response. And then this looks like we've got an error, which is a really telling thing for SQL injection. If you can throw a database error, the chances are you've got SQL injection. Obviously, in a lot of production environments, you're not going to have error messages switched on like this, or you won't have verbose error messages. You might get something generic back. But the fact that even if it doesn't say fatal error, uncore SQL exception, even if it comes back saying, hey, there was an error versus your blank payload where there's no error, that could be an indication that we have SQL injection. And it gives us a stack trace, which is quite nice. This is good for troubleshooting if you're in a more complex scenario. And then we also get 1 or 7 equals 7. So this is a good indication that if we look for a coffee where the roast level is 1, or 7 equals 7 is a true statement, if we change this to 7 equals 6, the DB shouldn't return any results. So we're testing for true-false statements, which is a great way to test. And we'll look at that in a second as well. So just looking through the results, you can be pretty sure that we are indeed vulnerable to SQL injection. So let's switch over to manual testing, and we'll come back and we'll do it as though we didn't already fuzz and we don't already know that there is injection there. So Control-R to send to repeater, and all I'm going to do is I'm going to send this as my initial request, and I'm going to pay attention. So 159 is the content length, and we get 2 results back. So it's a good idea to familiarize yourself with what a normal payload looks like and what a normal response looks like. So now I'm going to add a single quotes, because a lot of SQL queries will use quotes around their variables or their input. And so sending a single quote or a double quote can break the SQL, and that can trigger an error. So this is a really simple way of testing for SQL injection. And you notice that, yeah, we get a fatal error because we've basically interrupted the query syntax and we've broken it, and the database no longer understands this syntax. And we can also do things like where we saw or1 equals 7 equals 7, we can do or1 equals 1 to test whether we have true-false statements. So I need to URL encode this because spaces in the request line here are very important. And you can see that we get more results back. So our content length is higher and we get 1, 2, 3, 4, 5 coffees back. And so what we're saying here is select all from coffee where roast equals 5 or 1 equals 1. And because 1 equals 1 is true, it's selecting all. So this is forcing a true statement. And if we change this to, let's say, 1 equals 2, we only get the ones that were originally selected back. So select all from coffee where roast level equals 5 or 1 equals 2. So the roast level equals 5 is the true part, so it's selecting those still, and then not returning the false statement, or the false part of the statement. And we'll use this again later on for the authentication bypass. This is also a technique that can be used when we're dealing with blind SQL injection, which we'll briefly talk about later on. All right, so now we have SQL injection. What can we actually do with this? Well, one attack is union select, and what union select does is it allows us to grab data from different tables, which is very useful as a database administrator. And in this case, I'm going to tell you that there is a users table, and in the users table there are users with a username and password. And so instead of just returning the ID, name, origin, roast level, what we also want to return is union select username, password from users. So it's saying select all from coffee where the roast level equals 5, and also select the username and password from the table users. That's what this statement means. And this actually probably won't work because when you do union select, there is a constraint. You must select the same number of columns as your original query. And you'll notice that here we're selecting 1, 2, 3, 4 columns. And afterwards, we're only selecting 2 columns. So let's run this and see what happens. So I'm just going to encode, Control U, or you can right click, convert selection URL encode key characters. Hit send, and we get this error, which we expected, and you can see that it says different number of columns. Now, if we didn't know the number of columns, we could test, so we could just keep adding columns until we get our result. But if I just Control-Shift-U, by the way, undoes the URL encoding, we can add null, and we can add null again. So we're still selecting 4 columns, but 2 of our columns are null. We could also select other things that we want from the table users, such as the ID. So in this case, let's URL encode this quickly. Send this. You can see that we get the coffee back as expected, but we also get admin and the admin's password, and Jeremy's password. And if you want to kind of have a play with this, for example, if you change null here, you can kind of see how if we change the query and I put the password into the last column here, the password now appears in the roast level back here rather than in the name. So hopefully that gives you some understanding as to what's happening with the SQL query under the hood. So this is a way that we can go from basic SQL injection to stealing data. And often we'd try and steal things like the administrator password or the password hash, then go and crack it. Or we'd try and steal other data from the database as well. And one last thing to consider is that some databases we can actually get code execution from, depending on the database user, their privileges, and how the database has been configured. Now, I know that's a lot, a lot to take in, especially if you're new to SQL injection. So I highly recommend going and studying a little bit more on SQL injection generally, because it applies just as much to attacking APIs as it does to attacking traditional web applications. All right, so let's take a quick look at fuzzing with FFUF. And all we're going to do is come into here, come into a new tab. And we're going to do the same thing as basically what we did in Burp Suite. So first of all, we actually need this endpoint. So we're going to grab this payload. So /v1001.php. And we're going to go ffuf-u http / localhost, and then, whoops, I got 2 slashes here. And then we're going to change this 5 to fuzz. Now, because we have a question mark, I think we're going to need to put this in quotes because Bash may not like this question mark as a special character. I could be wrong. You'd have to check. And for the word list, what we're going to do is we're going to use, I think there is a word list in seclist. So, whoops, user share seclists. And then if we go into fuzzing, and then there it is, SQLi. And then we have some SQLi word lists. So let's go for the generic SQLi and see what comes back. And you can see that it gives us the payload, and it gives us the status code and the size. And again, you can see that the fact that we're getting lots of different status codes and we're getting different response sizes probably means that we have SQL injection. It's not always the case because it may be returning some value back. It may be saying, hey, this is not a valid request, or this was rejected. And then if it includes the text within the response, the size may be different as well. So you need to go in and verify that the attack actually worked. But this is a quick way to understand whether a endpoint is likely to be vulnerable or not. And then you can go in, copy and paste some of these into Burp Suite Repeater and test and make sure that it is. All right, so next up, let's take a quick look at SQL map. And what I'm going to do is I'm going to come into Burp Suite. I'm just going to grab this request, the clean request, the one that doesn't have all of the injection on the end, and just returns a couple of results. Come back here, and whatever text editor you want to use, you can use Vim, Nano, Notepad, doesn't matter. I like Vim, so I'm just going to create a file called req or request.txt. You can call it anything you like. Insert, and I'm just going to paste this in. So if I cat this, you can see it here. And all I'm going to do is I'm going to do SQL map -r for request, and then pass in the request.txt. Now, SQL map is quite a powerful tool, has a lot of options, so I definitely recommend -h, have a look, see what it can do, and do some study. But for today, we'll just have a quick look, and it's going to ask us some questions. So it's saying, it looks like the backend DB is MySQL. Do you want to skip payloads for other specific databases? So it's basically saying, I think it's MySQL. Do you also want to test for Oracle? Do you also want to test from Microsoft SQL Server, Postgres? And let's skip because we know that it is indeed MySQL. Do you want to include all tests? Yes. And then it comes back with not authorized. Try to provide the right HTTP credentials. And what we can do is we can just pass this ignore code. It's giving us some good advice there. Oops. Ignore code 401. And then we'll just do yes, yes. So it's really important to read what's happening, and different applications will respond in different ways. In this case, that 401 unauthorized is probably not the correct response code for what's happening with the interaction, but each application will have its quirks, different response codes, different coding styles, different schemas in terms of structure, and this is why manual testing will always be more effective than automated testing. So get parameter roast is vulnerable. Do you want to keep testing others? Let's not test. And then here it gives us some payloads. So it gives us the roast equals 5 and 2373 equals 2373, which we already knew about. We saw the 7 equals 7 in our fuzzing list, and we also tested 1 equals 1 and 1 equals 2. And it also has another error-based payload and a time-based payload as well. And I suspect we can actually just verify this and just go and sleep 10, for example. And it should give us 10 seconds before coming back. And you can see the fact that it hung and hasn't given us a response back does indeed show that we have time-based SQL injection. I'll give that a few seconds. Hopefully it'll come back. There we go, eventually. I think that was a lot more than 10 seconds, I'm not sure. But we got a 401. And again, this is probably the incorrect response code for what we sent it, but each application is going to react differently. And we got a generic union query as well. So here, this is quite a complex looking query, but you can use this as a foundation. So roast equals 5, union selects, and then we can start building targeted payloads based off this. And then one other thing that we can do is we can do something like dump, where it's just going to grab all of the data. It's going to use those identified vulnerabilities, and it's going to spit out the data from the database. So here we have the two users, admin and Jeremy, and their passwords, and we have all of the coffees as well. So SQL Map, really powerful tool, really useful, even if you're just using it for your initial recon to kind of see what payloads might work, and then you tune on that. Or if you use it just to dump the database or try and get a shell, which I don't think this will work, but let's give it a try. PHP. Yeah, unfortunately, because the user on the database doesn't have write privileges, we can't upload a shell. And it tells us that here. So process user has no write privileges, which I did on purpose. The user is only able to read the database. It's not able to insert new data, for example. All right, that was quite a lot to get through. So don't worry if you need to go back and rewatch. Feel free to have a play with SQL Map and Burp Suite and FFUF yourself. Doing is always going to help you reinforce everything you've learned. And in the next video, we'll have a look at a common authentication bypass. All right, so let's take a quick look at this login, and I'll just move myself out of the way. And what we're going to try and do first is let's just log in as admin, something that's always worth trying. And we get, sorry, incorrect credentials, but that's okay. What we're going to do is we're going to come over to Burp Suite, come to our proxy, HTTP history, and we can see that it's hitting the endpoint 002.php. And you can see our username and password and the response that comes back. So I'm going to send this to repeater, and we could do the same. We could send this to intruder, fuzz for SQL injection, and we'd probably fuzz this area here. So we'd get, do our usual quotes and things like this. And all I'm going to do is send this so I can see the response again. So I can see that the content length is 86, and I can see what the expected or normal response is. First, let's take a look at what we think the query might be. So this is just so I can try and explain this a little bit better and hopefully get you into the mindset of trying to understand what's happening behind the hood and then testing your theory to see whether you're correct. So the theory probably looks something like select all from users, where username equals username and password equals password. And these are probably variables, so we'll just put them like this. So first off, what we can try and do is we can try and manipulate the username and add our or 1 equals 1, and then comment out the rest of the code. Or we can try and add our payload to the end of the password and do or 1 equals 1, and then we should be good to go. And let's just give this a try and see what happens. So we have or 1 equals 1, and we'll send this, and we get, sorry, incorrect credentials still. Now that's interesting. So that means that we either didn't manipulate the query in the right way, or this isn't vulnerable to SQL injection. So we kind of got ahead of ourselves a little bit, and what I'm going to do is I'm actually going to just send a single quote here and see whether we do have SQL injection. And as you can see, we trigger an error, and so we probably do have SQL injection, but our payload is just incorrect. So my next theory is that this query here, instead of being unquoted, these may be put in quotes. And I know this just from having a background as a developer. There are many ways to write SQL. So what we can try and do is try and add our payload. So knowing that we can inject into here, so we could inject something like A, close this quote, whoops, and then put our or1 equals 1. And you'll notice that we have this trailing quote at the end. So to deal with this, instead of doing or1 equals 1, we can do or1 equals 1 like this to make sure the syntax is correct. And there are some other ways of dealing with this. We could do or1 equals 1 and then try and end the query so that this trailing quote becomes a comment. But you can try out different ways and see what works for you. So I'm just going to copy and paste this, put this in here, hit send, and we get success. We're logged in as admin. Let's try this on the front end as well. We're logged in as admin. So this is a really powerful concept to know, as it can be used against many vulnerable endpoints regardless of whether it's a login or not. So that's it for SQL injection. In the next video we'll cover NoSQL injection, something that you're definitely going to run into if you do a lot of testing of APIs. After that we have a nice challenge to tackle over on the crappy application, which will prepare us nicely for the mid-course capstone. See you there. The general theory of NoSQL is similar to traditional SQL injection, in that we're interfering with the query that gets executed. However, the style of NoSQL is a little bit different, so we'll do a quick primer on NoSQL and MongoDB before taking a look at the lab. I've included this because of the increased popularity of NoSQL, and you'll find that many APIs are backed with MongoDB these days, and MongoDB is currently the most popular NoSQL database. So let's take a look. So I'm just going to drop into a Mongo shell to begin with, so Mongo sh. And here you can see we've connected, so don't worry too much about what's going on. But what we'll do first is we'll use DemoDB. So here we just type DemoDB, and you can see that we've switched to DemoDB. And I suspect I'm going to be in the way, so I'll just move myself out of the way for the time being. So now we're using this database called DemoDB. We actually need to create a collection, but MongoDB, because it's quite flexible, will create a collection for us when we try to add data. Now, collections are like tables, but they're not constrained by the columns. So for example, if you add a user to a collection, you can give it a username, a password, an age, and other properties. And then if you add another user to the collection, maybe you just give it a username and password and you don't give it an age, for example. Imagine that you can basically add columns on the fly, but they're not required by default. So let me show you quickly. So DB, which is the current DB, so we're DemoDB, and I'm going to call the collection users, and I'm just going to use the insert1 command like this. And I'm going to pass in a JSON object, so I'm just going to put name, and we're going to have Jeremy, and let's say Jeremy's password is cheesecake, like before, or I think before. And let's give him a country as well, so let's say that Jeremy is from, Sweden. And now we get acknowledge true, and it's inserted it. And if we want to see the collection, we can do show collections, and we have our users collection. And if we want to list everything in there, we can do db.users.find, and it will list everything in there. So in this case, Jeremy has an object ID, and he has a name. This is automatically created and assigned, by the way. We didn't have to add this ourselves. So we have the name Jeremy, the password cheesecake, and the country Sweden. If we add another user, let's say that we add Jessamy, and Jessamy's password is tiramisu, and Jessamy is from Scotland, but Jessamy also has an age and she's 35. And then now when we find, we see we have Jeremy, his password is cheesecake, his country is Sweden, but Jessamy is also in there with a name, password, country, but also the age of 35. So if we want to find just one user, we can do db.users.find, and we can pass in some parameters. So for example, we can just say, I want all users of age 35. And it just returns Jessamy, because Jessamy is the only one with the age 25. Again, you might want all users with the name Jeremy, and it will pull Jeremy. And if we have some duplicate entries, so for example, there are 2 Jessamys, and this one prefers lemon tart, for example, but lives in Wales and has the same age, you can see that it doesn't mind us having repeated fields because these are not necessarily unique. And when we do find, we can find all the users with the name Jessamy, and it returns both Jessamys. Now, one other thing to consider is that we also have JSON operators, and we're going to use these operators in our injection tag. So for example, a typical login query might look something like db.users.find, and it might have name, and obviously we pass in the name Jeremy, and it might have the password, and we pass in Jeremy's password, which, if I recall, is cheesecake. If we don't supply the correct password, let's say we know he likes cheese but not cake, it doesn't find Jeremy. So this might be a typical login query that is part of our application. What we can do is, if we have control over this, we might want to input something like a JSON operator. So we could say something like the password is not equal to 0, for example. And this returns Jeremy. And obviously, as long as we don't put the correct password in here, so not equal to undefined or blank, we'll also pass Jeremy. So in this case, we can use JSON operators to bypass the logic of the application's NoSQL queries. So let's take what we've learned here and apply this to the lab. All right, so I'm in the labs folder, and as you can see, I have the API NoSQL injection zip. So I'm just going to unzip this. You can see there's quite a few modules in there. This is because it's using Node and Express. And we're just going to cd into this folder, clear ls sudo docker compose up. And we'll give it a minute to build the application. While it's doing that, I can load up Firefox and also Burp Suite. And it doesn't matter whether you have the professional or community edition, we're just going to use the repeater for this one. While this is loading up, actually, I should say that basically fuzzing for NoSQL vulnerabilities is exactly the same as fuzzing for SQL injection vulnerabilities, except that your word list may be a little bit different. So if you have seclists installed, if you don't have it installed, you can install it with sudo apt install seclists like this, and it's going to tell me that I've already installed it. And then if we come into seclists, so if we ls user share not word lists, seclists. And before we used the fuzzing, and I think we used the SQLi, and there are some SQL word lists in here. If we come back and we go back into fuzzing, and we come into databases, and you'll see that there is a nosql.txt file here. So If we just cat this, for example, you can see that this is full of NoSQL injection payloads. So if you're fuzzing for NoSQL injection, you'll want to use a list like this rather than the traditional SQL injection lists. So let's come back to here, and we got a warning. This is because I have Mongo already running, I think. So sudo systemctl stop. And let's try again. Trying to use the same ports that MongoDB was already using on my system. All right, so let's come into localhost. And we have our NoSQL injection. Now, if there are no current users, feel free to add some. So for example, we have Jessamy, we can add the username and password, Jessamy, and this will add it to the current users. But if there are already some there, then you can carry on with the exercise. And this is just to demonstrate NoSQL injection. So if I log in as Alex, you get a success, logged in as Alex. But if I log in with the wrong username or the wrong password, we get, sorry, you provided incorrect credentials. So let's switch on our proxy. And I'm just going to add in asd and hit login. And then come to Web Suite, come to proxy, HTTP history, localhost. And we can see that this is kind of a bad practice, but I think it's okay just for our demonstration labs. But obviously, when you log in, you don't want your username and password being passed via the URI. If you ever see this in a web application, you should report this as an issue or a finding. So let's just send this to repeater, and then we'll send it once so that we can see. And I think the message that comes back is sorry. So I'm just going to add sorry into the search here. And if I move myself out of the way, you can see that we have one match down here in the corner. So if I send a request and I don't see this one match, I know that my request has been successful. Or what you can do is you can render the page and look at it yourself. All right. So here, what we want to do is let's try and log in as admin. So we'll send another request. It comes back as 200 OK, but we have our one match saying, sorry, you provided incorrect credentials. So what I'm going to do is, instead of doing something like or 1 equals 1 here, I'm going to say that I know this is the incorrect password because we get the sorry, your provided credentials are incorrect. And here I'm going to inject a not equals. So our query is going to say, hey, db.users.find, username equals admin, password not equals to asd. And you'll see that when we send this query, we get 0 matches. And if we render it, we get a success, you logged in as admin. So as you can see, the theory is quite similar. We're manipulating the query to get the results that we want from the database. And if you want to know a little bit more about NoSQL payloads, you can come to something like payloads all the things on the Swiss key repo, something that you probably already have bookmarked. If you don't have it bookmarked already, then please go ahead and check this resource out. And if we just search for NoSQL injection, you'll get a page where you have a number of payloads. If you're working in JSON or PHP, for example, and also some scripts to deal with NoSQL injection as well. And as you can see, where we have a username is not equal to Toto or Tutu, and password is not equal to Toto or Tutu, and the JSON equivalent here. So the username is not equal to the null, and the password is not equal to null, and this is our JSON operator here. So depending on the underlying technology, you need to decide which payload to use and then go from there. Alright, that's it for our SQL injection primer. I hope you got some insights into fuzzing, testing, and exploiting SQL injection. Of course, feel free to go over the labs we've done yourself to help you solidify the topics and test out different payloads and methodologies. I also have a small challenge for you as well to make sure that we solidify what we've learned. Let me bring you to my VM. So here we have the dashboard of the crappy API application. And I'm going to take you over to the shop, and here we have the coupons or add coupons endpoints. And this is the endpoint that I'd like you to assess and see if you can achieve SQL injection. So one thing that I do want to mention, if you're using Burp Suite, is a little quirk that might catch you out. So when using Intruder, Burp Suite usually has this payload encoding ticked automatically. So if you're fuzzing word lists and you've tried a bunch of things and you don't find anything, maybe try not using URL encoding, for example. And also with your payload, be careful with where you place your highlighting. So for example, if I have a payload that says Alex like this, I might want to test adding something inside, but this may be passed as a string, so I may want to also test something, adding my payload over the top, including those two quotes. So have a play around with it. I know that these things can catch you out, so they're worth bearing in mind as you're testing. Good luck with the challenge, and I'll see you in the next video. Alright, welcome to the final video of the section. I hope you got on well with the challenge. Congratulations if you solved it. If you didn't solve it, don't worry, we're going to walk through it together. Make sure that you take notes and learn from this experience so that you're successful next time. So let's dive straight in, and I'm going to jump to my VM, and we're just going to come in and enter a coupon code, ASD, and hit validate. And unsurprisingly, we get invalid coupon code. So I've already got traffic going to Burp Suite, so I'll just switch over to here. And interestingly enough, we get a 500 internal server error. So let's send this straight over to Intruder. So we hit Control-I, and let's take a look. So I think I left a hint for this, but the first thing I want to think about is this payload that's been highlighted. If we send all of our payloads that are enclosed in quotes, it's probably going to be interpreted as a string. So what I'm going to do first is I'm going to clear this, and I want my payload to be the whole thing. So that's one thing that I'm going to do. And the second is I'm going to come in and I'm going to load in a SQL injection payload list. So I'm just going to click add from list, and if I can find it, SQL, fuzzing, SQL injection, and then I'm just going to click start and see what comes back. And I'm looking for the same things that we looked for in the lab, so status code and length. And I think all we can really see is one status code of 500 if we send the initial request, and then we get 422 after that, so unprocessable entity. So it doesn't actually like our input, but interesting that we're getting some different results back, some different error messages back, which again hints that we might be able to get SQL injection. So error messages in this case are always a good thing. So what I'm going to do is I'm going to clear this, and then there's not a NoSQL injection list included in Burp Suite, so I'm just going to load. And then I'm going to go to, I'm going to go to user, share, seqlists, and then we're going to try discovery. Nope, we're not going to try discovery. We're going to try fuzzing and databases, and there is a NoSQL list here. And as you can see, this is all NoSQL, and things like greater than are very similar to not equals. So these are some of the payloads, or similar to the payloads that we used in the lab. So the list isn't very long. I'm just going to hit start attack. And interestingly enough, we don't really see many results. So all the status codes are the same. We do get some different lengths. But they're all very close to together, so 459, 447, 449. I'd want to see something a little bit more out there to verify this. So what I'm going to do is I'm going to come down, and I wonder if the URL encoding is breaking this. So I'm just going to switch off URL encoding. Always something to try if you're not getting any results or any luck with your results. Click Start Attack. So we can come down and again we get 422, and actually if we look closely there is a 200 here in the list. So it looks like greater than blank actually yielded some results and we got our coupon code. We would have also seen this if we'd just skimmed down the list, and you can see it kind of blink up, but the length isn't that different. So in this case, it would have been tricky to see from the length, but the status code gave it away. If we'd grepped for the reverse of invalid, we would have also found this as well. So let me show you this quickly. So we'll just go for invalid, negative search, hit apply, and you can see that we find our results. So if we had tens of thousands of results, this would be the most effective way of finding it, or by filtering on the status code. Again, depends on the situation. We've got to exhaust all possibilities, and being thorough is really a big part of web application security. So that's it for this section, and I hope you're enjoying the journey as much as I enjoyed making these videos. Our next stop is the mid-course capstone, so I'll see you there. Welcome to the mid-course capstone challenge. You've done a great job so far in this course, and I hope that you're improving your workflow and learning about new vulnerabilities to test. In this section, I'm going to give you a small application to test. This is built in a way where each individual part has kind of been created, but the overall architecture and design of the system has been somewhat neglected. During this challenge, you're free to use any tools or attacks that you'd like, but remember that it's designed to demonstrate the topics we've covered so far. You'll likely find other common issues such as CSRF and lack of hashing, and if you want to use this as an exercise to find those kinds of vulnerabilities, then by all means feel free to do so. I'm just going to spin up the lab so that you know what it looks like and where your starting point is. Let's jump in. So as usual, I just have the zip file here ready to go. So I'm just going to unzip API mid-course capstone. And here we have the API mid-course capstone folder. So I'm just going to come into this, clear my screen, and you can see the files. And then as usual, we're going to sudo docker compose up. And something to note that this web application runs on port 80. So if you have Apache or something else running that's already using port 80 on your machine, it might throw an error saying, hey, port's already in use. And all you need to do is go in and close down Apache or whatever it is that you have running on port 80. So once we have this running, we're just going to open Firefox, and then we're just going to come to localhost, hit enter, and we get this main page. So you can see we have some register, login, order coffee, track your order, and a view stock buttons. So this is the application, and it's up to you how much time you spend on this, but make sure you have a good go at trying the techniques we've covered. Good luck, and I'll see you in the next video. All right, welcome back. Let's take a look at the application. I hope you got on well and found some interesting vulnerabilities along the way. So I'm going to walk you through some of the main things that I wanted you to find and things that we've looked at throughout the course. If you found extra stuff, then congratulations. And let's dive in. So here we are at the main page. So first thing I want to do is look at these buttons. So it seems like we have 3 major buttons plus a login and register. So I'm just going to click on view current stock. And it seems like we have 3 types of coffee. So Revival, Rise and Shine, and Jitters. And they come from different regions. And so we can see Ethiopia, Brazil, and they have different roast levels. So I'm just going to click this. This brings us back to the home page. And also what I'm going to do is just switch on my proxy. I probably should have done this straight away. So I'm just going to come back and browse to here and then come back. And this is just so I'm capturing all the traffic as I walk through the application. And I'm just going to go with track your order. Seems like we need an order ID. Nothing comes back if we just enter ASD. Order coffee gives me a login screen. Okay, so this is about the time where I think about registering, and I'm just going to register a user called Alex. New user created. Close this. Looks like we can just go ahead and log in. And we successfully log in, and we notice there's some slight UI changes. So we have a logout button instead. And again, just have a quick look around, see if anything interesting has changed. And come to order coffee. And it looks like we can place an order here. So something that I also want to look at is I have this cookie plugin. So just have a look at this. This looks like we were given a session token, which looks like a JWT because it's got 2 dots in it and looks like it's base 64. So this looks like the header up here, then the payload, and then the signature at the bottom. And I'm going to go ahead and order 1 kilogram of jitters. And we get order placed and we have an order ID. So I'm just going to load up mousepad. Paste this in so that we can see, refer to this later if we need to, and then come back and click close. And what I'm actually going to do is I'm just going to paste it in here to see if I can track my order. And it does look like we have an order, and the username is Alex, and it's pending. And this looks a little weak. It's not a very long, unique ID, and looks like it's mostly numbers with 1 letter as well. So we might think about testing that soon. So I'm just going to come over to Burp Suite and we can have a quick look through the traffic. So I like to kind of see what's going on here. And I can see a lot of /v1 and /coffee.php. So let's take a look and see what this endpoint is giving us. And I will just move myself out of the way so that we can see what's going on. And this looks like it just returns the 3 available coffees from the system. We have a functions.js. This looks like this is the front end that's handling all of the requests. So yeah, you can see check if logged in, close buttons, stuff like this. We might come back and take a look at that later on. And we have this track. So ID is ASD. So this was the first tracking query that we did. So we can maybe try and brute force this because we have a order ID now that we can use. We might have an idea of how we can get other coffees. And we have /auth. So this was our new user created. And there are multiple calls to /auth. So this looks like this one was the login one, which returned our JSON web token. And then we have an order here. And this is quite interesting because when I placed an order, I didn't specify my username or email address. So it seems like the front end actually generated this. Now, this isn't necessarily a problem, but what looks like has happened is it's taken the information from my session ID, placed it into the request. If this isn't verified in the back end, what might happen is we may be able to place users on the behalf of another user. So let's take a quick look at the token next. I don't think there's much else to look for in here, but I hope this kind of gives you an idea of how I like to approach an application. I click through everything, have a look and see what's in the requests. Something that I did forget is adding these images, other binaries, and CSS. I like to be able to see everything. And let's take a look at this JWT. So I'm just going to go jwt.io. Scroll down. Oops. Accept the cookies on here. Paste this in. And as you can see, we have a username, Alex. So I think what I'm going to do is I'm going to do a little bit of A/B testing. So I'm going to close this, log out, register a new user called Alex2, and the password is going to be Alex2. And hopefully I get a new cookie, which doesn't look like... Oh, I need to log in first. So Alex2, close, and I get a new cookie. So let's copy this and paste. And here we have Alex2. If you don't have this plugin, by the way, you can also do things like, let's come into here. If you want to see the cookies, you can just do document.cookie, and you can grab the cookie from here as well. Let me zoom in so you can see that. So this is another way of grabbing the cookie from the console. But we can see we have Alex2. So since we're logged in as Alex2, what I'm going to do is try and order something as Alex1 and see whether this works. I would try just changing the name and then sending it. And then I would also try sending it without the signature to see whether it accepts a null signature. And I might then try other attacks like changing the algorithm and header injection and things like that. But to start off with, what I want to do is test the basic functionality of the website. And then I kind of go deeper and deeper based on the behavior and the responses I get. So I'm going to click order coffee, and then I'm going to come to Beb Suite, and I'm going to switch intercept on, and I'm just going to hit place order. And I don't think I actually need the token here. So, oh, yes, I do. I'm going to paste this token in, this updated token, change the name to Alex because I'm currently logged in as Alex2. So I want to see if Alex1, if I can place an order on behalf of Alex1. Seems like it went okay. And you can ignore this green highlighting. It's just from this JWT editor keys. If you want to install this plugin, by all means, but it will highlight when it detects JSON web tokens, and it does a bunch of other things as well. And I get this order placed. Now, if I check this order, so I can come back, track my order, I did indeed place an order on behalf of Alex, even though I was logged in as Alex2. So this is broken function level authorization. I'm able to carry out an action on the behalf of another user, or create an action or do something that is tied to another user account, not necessarily mine. So this is definitely a really important finding and something that we should be reporting. So next up, what I'm going to do is I'm just going to grab a fresh token. So let's log back in as Alex2 again. And I want to test to see whether this is using a weak secret. So I'm just going to come here, copy this. And the reason I'm testing this is because I saw HS256 here instead of the RSA version. And that means that we can try and crack this token. I'm going to come over to my terminal, Control-Shift-T to open a new tab. And then we could use Hashcat for this, but I'm just going to use JWT tool, and I'm going to do -C to crack, -D to specify a word list. So user share word lists. Let's just use Rocky for the time being. And then I'm going to copy in the token. Hit enter. And that was very fast. It says here, coffee is the correct key. So not only have we discovered that we can carry out actions on behalf of a user because the token is not correctly checked in the backend, we've also found that a weak secret is used. So that's two critical issues that we have found. Now, we haven't done much discovery beyond clicking around the application, so I think it's about time that we come back to here and we take a look and see what else we can find. So I'm just going to copy and paste the URL, and we already know we have /v1. So let's come back to here and use fuf-u. And what I'm going to do is I want to see if there's anything else behind /v1. So if there are any other endpoints. So we have coffee.php, auth.php. What else can we find? So come here, word list, user share, word lists. We'll use deb, we use the big one. And we want to use the extension PHP as well, because we know that a lot of the endpoints have the .php extension on them too. So instantly we find coffee and track and admin. We haven't seen admin before. So let's just come back to here and do /admin. Oops, /v1/admin. And we get a forbidden, which is not surprising. But we can continue our attack, so we can do something like recursion and turn on recursion. But often I just like to step through and see. It depends on how many endpoints we're dealing with, really. So let's do admin/fuzz. And we do hit this result orders.php. And this looks like it returns all of the orders for us. So this is a endpoint without any protection at all. So this is a really, really important finding. And we'd say that, hey, even though it looks like the front-end application isn't accessing admin, we didn't see it anywhere in our logs. That's kind of security through obscurity. It's hidden in a directory, but we know that it's quite easy to discover and browse to directories. And in the real world, you'll find things like configuration files in random directories, and you will find stuff that isn't intended for the end user, but it's still live on the site because the front end simply doesn't point to it. Maybe somebody hasn't found it yet. And I think the last major vulnerability for us is these order IDs. So if we grab one of these, we need to test for broken object level authorization. So if we come back to localhost, because we have a track order functionality, we should only be able to see the orders that we created. So if I just log out and I log in as Alex to make sure that I'm testing correctly, come to track order. And if we grab an ID that belongs to a different email, so we can see this one belongs to ASD2. Paste this in, and we can indeed see the orders of other users. So this is broken object level authorization. This is a Ebola vulnerability. If you wanted to go a little bit further, you may be able to harvest these tokens, take them into Burp Suite, do some analysis on them in Sequencer, and find some more information there and see whether you can actually forge or easily brute force these IDs as well. So that's it for the mid-course capstone. I hope you enjoyed the challenge, and even though the application isn't very large, I wanted you to be able to focus on smaller parts of the application, understand how they work, and try to exploit them methodically. From now on, we'll be ramping it up a little bit and looking at slightly more complex attacks such as mass assignment and server-side request forgery, so I hope you enjoy the rest of the modules. See you in the next. Often, frameworks or particular styles of coding allow us to write code that's flexible enough so that when we assign HTTP parameters to variables, it's done automatically. For example, some code might receive a request that contains information to create a new user. Some of these requests will have the username, email, and password to create that user. Others might include optional fields, such as telephone number, address, favorite cheese, etc. As attackers, we can sometimes leverage this flexibility to include or modify parameters that the developers did not expect, parameters that might have some impact elsewhere in the application. For example, if all users have a privilege level by default, we might include a parameter in our request that sets the privilege level to 1, overriding the default value. This is mass assignment, and it sits at the number 6 in the OWASP API top 10 list. Definitely something we need to understand and test for when we're working with APIs. Now, you might be wondering, how do we find out what the parameter names need to be in order to exploit this vulnerability? And this is a great question, because if we didn't know what an application tracked for its user privileges, and if we didn't know what the values were, in this example 0 and 1, we may not be able to exploit this vulnerability. There are some ways we can find out this information, however. First off, if the application is open source, discovery is fairly trivial. Second, if the application uses JWTs, we can decode the token and see the claims of the user, and then try to set these claims on new user creation. We can also look at what information is returned by endpoints. So for example, if you browse to /account, you may see all of the parameters tied to your user account returned. And if you see something like isAdmin false, you know you're on the right track. I think I've mentioned this a few times throughout the course, but getting to know the application and understanding its behavior is really key to being successful. The discovery and understanding is the hard part. Exploiting something once you find the vulnerability is generally trivial. In the next video, I'll walk you through some code of an example and demonstrate how to exploit the mass assignment vulnerability. See you there. Alright, so before we dive into the hands-on section, I wanted to walk you through some of the application code. First, it'll help us understand the vulnerability, and if you ever need to pass on the explanation of mass assignment in a report or a presentation to a client as part of your work, or maybe to some other developers, then you're welcome to use this example to support that. Secondly, I'm a big believer in code review. So if this is something that you're not used to but want to improve, then small applications like this are a great place to start. Let's take a look. I'm just going to pull you over to my VM, and what we're going to do is you can see that we have the API mass assignment.zip as usual. So we can just unzip API mass assignment, clear this, cd into API mass assignment, and then we can see the files in here. So I'm just going to open this up in Visual Studio Code, and we're going to take a quick look. So let's start off with index.js. We can see that line 1 imports Express, and this is a Node. Express is a Node framework that basically provides tools and functionality for us to create web applications a little bit more easily. Let me make this a little bit bigger for you, and also probably just move myself out of the way because I will be in the way at some point. Next, we have Mongoose, which basically provides us with a way to interact with MongoDB using JavaScript objects and data structures. And if you're not sure what a data structure is, then we'll talk a little bit more about it in a minute when we come to look at our user. So the next line is const app equals express. This creates an instance of the Express application. And then we have app set view engine EJS. Now this is for a templating engine that I like to use, which is EJS, and basically lets you embed JavaScript code into HTML templates. Nothing really out of the ordinary. Maybe we'll take a quick look at the template in a minute. App.use express.url encoded. This line tells our application to use Express's URL encoded middleware. And the next line is Mongoose, so this is quite an important line. This block connects to the Mongo database using Mongoose's connect function. The database is at MongoDB, Mongo 27017, and then /NoSQLi demo. And you can see that obviously I copied and pasted the previous lab to save a little bit of time rather than creating it from scratch. And if the connection is successful, we get the .then method, which logs a message to MongoDB saying MongoDB connected. And when you run this, hopefully that's what you'll see in the log. And if it's unsuccessful, it'll trigger the .catch method, which will print the error message to the console. Next up, we have const user equals require, and then models/user. Here, we're actually importing the user model from models/user. Now this represents the schema for user data. And you might be thinking, what the heck is a schema for a user? A schema is essentially a way of defining the structure and validation rules for the data that will be stored in the database. For example, the schema might say that all users require a username and a password, and that the password is not allowed to be null and the maximum length is 50 characters. These constraints are all reflected in the schema. In fact, let's take a quick look at user.js. So if we come into models and user.js, we have our first two lines. So these two lines import the Mongoose library and creates a new instance of the schema class that's provided by Mongoose. And as we now know, the schema class is used to define the structure and validation rules for data that we're going to store. This next section is our user schema. We have 3 fields, so we have username, password, and privileges, and we also have some validation or constraints around these as well. So for example, they all need to be strings, and the username and password are required. And also the default value, all 3 are required. So username, password, privileges, and the default privilege is user. This final line, module.exports, equals user mongoose.model user schema. This final line exports the user model so that we can use it in other files. And as we just saw in our index.js, the user equals require model/user. It basically makes this schema available for us elsewhere in the application, and also allows us to do things like user.find, user.create, very handy stuff. So coming back to the main index file, think of this as the rules we use to describe the constraints of our objects, such as users, products, posts, messages, and anything else that can be quantified within our web applications. Now next up we have some routing. So our index page, this will trigger when a GET request is sent to the root URL, so /. So if the website is www.tcm-sec.com, if you just go to that top level address, then this will be triggered. So when this happens, we use the user.find method to grab all of the users out of the database, and then we render the index template and we pass in the users that were found. After this, we have /register, so similar to the previous block of code, except that this will only accept post requests. So if you post some data to /register, this will trigger. And we have a const new user, which creates a new user object using the request body data, so the data that you're sending in the request. And then it saves this to the database, so user.save. And then it saves this to the database using the newuser.save method. Once the user data is saved, the application redirects us to the root URL. Next up, we have clear. I just added this so you had an easy way to clear the database if things got a little crazy with adding users and fuzzing. Something to consider when working on production environments is that the staff maintaining the application might not appreciate 10,000 new users. And in some bug bounty agreements, if you read through them, it might say that you're not allowed to carry out attacks that create excessive amounts of data or database entries like this. So just be cautious when working on production applications. So here we have a GET request to /clear. The application deletes all of the user data from the database using the user.deleteMany method, then forwards the user back to the root address. By the way, if you're interested in learning more about how to build web applications such as these, I personally like Brad Traversi's courses. I'm by no means associated with him, but I find that his courses are practical and the videos are good. I use them myself to keep up to date with development practices and technologies that I want to learn, so you can easily find his content on YouTube. I hope that this quick run through of the code was helpful, and don't worry if it was a little bit overwhelming for now. We're going to run through the lab in the next video, so I'll see you there. Alright, let's take a look at the hands-on lab. So I'm just going to sudo docker compose up, give it a second to build the lab. Fingers crossed it works. So you can see that I've done a little bit of testing before, and so what I'm going to do is I'm just going to go to /clear, which is an endpoint that I put in so that it just clears out the database for you. So if you're doing some testing and fuzzing and things like that, I think we saw the code in the code review in the last video, you can just go to /clear and then everything gets cleared out. So let's create a new user called Jeremy, and his password is just going to be something random like cheesecake. And you can see here, might be text is a little bit small, that we have Jeremy, cheesecake, and user. And this user parameter is the privilege level. So what I want to do is, here it says we can add some users by posting to /register, or we could capture this request in Burp Suite and then head to the repeater. But in this video, we'll use Postman to do this. So what I'm going to do is I'm just going to hit new HTTP request, and then there's a little useful icon down here that just hides the sidebar for us. And what we want to do is we want to post to HTTP localhost /register. You can see I've already tested this, and we want to come into the body. And I'm pretty sure this is a form, so I'm just going to use the xwww form URL encode, but you can double check this by intercepting the request or inspecting it further. So I'm just going to put in a username, and let's call this Jessamy, and I'm going to put in a password, and Jessamy's password is tiramisu. And let's send this to see whether this works. And we get a response back here, so I'm just going to scroll down in the response quickly. So I know it's kind of hard to see, but you can see we have Jessamy, tiramisu, and user, and we can verify this in the UI as well. So to sign up a admin user, what we need to understand is where this user parameter is coming from. So there's a couple of ways to do this, as I think I mentioned in the introduction video. Obviously, if you have access to the application source code, it's very easy to find out because we can just come in and take a look at the user schema, and we can see that we have privileges here. We can also look at things like the account page, the JWT token, and all sorts of other things. We could fuzz for it as well. So we could send this to Intruder and create thousands of users and see whether we get one that's created as the administrator. So I'm just going to put privilege, and I'm going to try and put this as admin, and we'll just call this Jessamy2. And then we'll just come back to the UI, and we're still user. Because privilege is not privilege. We'll send this again. We see that there's no check in the DB to see whether the usernames are unique, but that's okay. And we have indeed created a admin user. This is mass assignment, this vulnerability right here. So it's actually quite simple once you kind of understand the application, how it's handling things, but obviously gaining that understanding can take time, can take a lot of analysis. But now you know the theory, you can apply that to your next engagement or scenario. So let's take a look at the vulnerable line of code. So if we just come back to Visual Studio Code, come back to here, and here we have our vulnerable line of code. And if you want to pause the video a second and kind of do a little bit of research and figure out the reasoning behind it, by all means, feel free to pause the video and do that. It's good code review practice to understand small snippets of code. And I'll see you in a second if you did pause. All right, so the issue here is that we're using this ... which is the spread operator. And this is used to pass parameters or properties from the request.body into our user object. And what it'll do is it automatically pass all of them in there. So in our Postman request, for example, if I also define something like, I don't know, cheese, and I put Parmesan, it would try and pass that in. Now, we do have the limitation of our schema, so that wouldn't get passed into the database, but it would still try and pass it into our object. A more secure way of writing this would be something like request.body.username and request.body.password. And then the user can never define the privilege parameter or the privileges parameter. And by default, our schema, it's created as user. And then probably what we would do is we'd implement some administrative functionality later on that allows the upgrade of users to admins, for example. But here, we don't want to include that functionality. So being quite specific is quite important when we're writing code like this. And one last thing I want to do before I give you all a challenge to take a look at is let's come and check the database and see. We sent a few different requests and see what's actually in there. So let's do sudo docker psa. We have a couple of images here. So we want the Mongo one, and then sudo docker exec -it, drop into a shell, Mongo, show dbs, use Mongo mass, assignment, and then show collections. And then what we want to do is db.users.find like this. And then we can see everything that's in the database. So if you want to come in and see what you've done or see how things have been entered into the database, you can come in and take a look. And when we accidentally sent Jessamy, for example, with the privilege instead of privileges, you can see that that value wasn't inserted again. So this data is conforming to the data structure that we set out, the user schema that we set out in our code. It won't just insert anything. All right, so as always, I have a little challenge for you as well. And then in the final video, we'll do a walkthrough of the challenge. So I'm just going to come out of this. In fact, let me pause for a second and I'm going to spin up the crappy application and I'll see you back here in a second. All right, it's challenge time. I'd like you to log into the crappy application and come to the shop page. Now, if we intercept the traffic, I'm just going to hit refresh, we'll see that we have this endpoint/products. And this is the endpoint that I'd like you to work on to find this vulnerability. And if you're able to successfully exploit this vulnerability, you should be able to increase your account balance. I do have one hint for you, but if you feel ready for the challenge, then feel free to stop the video here and dive straight in, and I'll catch up with you in the next one. If you do want the hint, then what I recommend is that don't just consider the payload that you're sending to this endpoint, also consider the type of request you're sending as well. Give it a try, and as always, we'll walk through it together in the next video. I'll see you there. All right, welcome back to the final video of this section. I hope you enjoyed the challenge. Congratulations if you solved it, and if you didn't solve it, as always, let's walk through it together and make sure you take good notes. Let's dive straight in. So here I have the crappy application as I just showed you all, and if we switch to Burp Suite, we have the endpoint that we want to attack. And I'm going to fuzz this endpoint really quickly, both with intruder and FFUF, and see what results we get back. So I'm just going to hit Control-I, send to intruder, and I'm going to add our payload marker here, and then come to payloads, and I think in Burp Suite there is a HTTP verbs list. Yes, there it is. And then we can just hit start. So it's going to get, post, head, connect, etc., etc. And as you can see, we get a 200 response on things like get, head, options. Can't see any others. So these are the request types that we should be analyzing or targeting in our pen test or in our analysis. And if you want to do this in FUF, let's quickly come over to the terminal and we'll just do ffuf-u http://localhost 8888, and then I just need the endpoint which I'm going to grab from Burp Suite. So, and then our word list, so users share sec lists, and I always forget where the word lists are in here because it's not, in my opinion, laid out that well, but that's okay. And I think, yeah, we have HTTP request methods that we can use. And then we just do -x fuzz for the request type or the HTTP verb. And here you can see we get similar results. So we get 200 for options, for example, and we get 401 for post, probably because there's no data. Interesting that this is different to what Burp Suite gave us, but different to the 405, which is the majority of them. So, and we can actually get rid of these by just doing -fc 405. And then it gives us slightly neater results. So just in case you missed that, -fc will filter out all of the 405 responses. So options, head, get, and post are the request types that we want to be using to analyze this endpoint. So let's take a closer look at this endpoint now in repeater. So I just hit Control-R for repeater, and let's send this request and see what comes back. And it comes back with a bunch of products, which of course are the two products that are on the page. Now, if we change this to post, for example, and send this, we get back 400 bad requests, but we actually get back a bunch of variables or parameters that we might be able to use in an attack. We could also discover this by looking at the traffic. So we have ID, name, price, image URL. So these are quite easy to find, but these are the parameters that we're going to inject into using our mass assignment vulnerability. So if I just come here and use extensions, content type converter, convert to JSON. And then what I want to do is, in my request, I want to add a name. And then let's just switch this to raw. It's a little bit easier to work with. And we're going to want 3 variables. So we want price, and then we want image URL. So here, let's put in some cheesecake and the price. What we're going to do is we're going to put this to -500, and then the URL. Let's just find a picture. Copy image link, and we'll use the same one. So localhost images seat.svg. And interesting that that's a SVG, which is a scalable vector graphic. I think this is based off XML. So maybe if we have image upload, we also have XXE, external entity injection, via this as well. Anyway, I digress. And what we want to do is basically just send this request. And we get JSON parse error, expected property. This is because I had one extra comma. And if we switch it to pretty, you can more easily see what's going on. And then we get a HTTP 200 OK back. So ID 3, cheesecake, -500, and the seat. So let's refresh this and see whether this has actually worked. Maybe we broke the application. All right, I'm not sure what happened there, but I switched off my proxy and then refreshed, and it seems to be okay. So maybe it's a problem with how Burp Suite is connecting to the application. But anyway, we can see that our new product was created and it's -$500. And then when we click buy, we get success, order sent successfully, and then we come back to the shop and we can see that our available balance is higher. And every time we click it, we get more and more available balance. So that's it for this section. There are a couple more mass assignment vulnerabilities inside of the crappy application. So if you have time, definitely challenge yourself and try to find and exploit them. I'll see you in the next section. So let's talk about excessive data exposure, a pretty simple issue that can come up for a number of reasons, such as poor design or lack of security training for engineers. We've actually seen this already in a previous module where we needed to find a vehicle ID to exploit a Ebola vulnerability. This was a great example because in well-defended applications, we usually have to chain issues together to achieve exploitation. This is also something that a scanner can't do, and as much as salespeople will tell you that their tool is amazing and powered by AI, I'm yet to see them successfully find complex issues such as second-order or chained vulnerabilities within web applications. So again, I just want to stress that understanding the target application, what it's supposed to do, and evaluating APIs in context is vital if you want to be successful. Let's take a look at some common examples of excessive data exposure, and keep in mind that when you find it, always think, okay, what's next? How can I use this? So there are a few techniques to thoroughly test for excessive data exposure. We want to be on the lookout for APIs returning full data objects and client-side filtering. So we can easily verify this by looking at what we see in a response versus what we see on the page or within the web application. Now, we've covered a lot of individual vulnerabilities during the course and using single endpoints as targets. Since we have the full set of endpoints for crappy available in Postman, what we're going to do next is run through them and see what we can find when we're evaluating one after the other after the other. I'll see you in the next video. All right, so we have our crappy application running, and we come into collections and our crappy Postman collection. And all we're really going to do is we're going to start at the top and we're going to run down through some of the key endpoints and see what data comes back. Now, of course, the best thing to do is run through all of the endpoints, get an idea of how they work, what they're supposed to do, And then the ones that take parameters, or the ones that we discover that we can post to or put to instead of just get, for example, we test in more depth to see whether they can leak further information. But to begin with, all we're going to do is go down the list and see whether we can find anything that looks out of the ordinary. So I'm just going to sign up a new account. We get user registered successfully. And I'm just going to move myself out of the way so you can see all of the responses clearly. And then what we'll do is we'll come to login. We log ourselves in. We don't necessarily need to, but we can just verify our JWT. And then forgot password and the OTP one-time password. I think for now we'll skip over these. We can see things like resend vehicle. So we can have a look at get vehicles. Nothing's returned. Get recent posts. And here is the one that we found earlier. So we can see these email addresses listed. And we can see the vehicle information, although this user doesn't have any vehicle yet. And then, of course, if we scroll down, we can see other users and other sensitive information that shouldn't be returned. So finding excessive data can be as simple as that, but it can also be quite complicated as well. So for example, if we have an endpoint that takes some data, for example, the get reports, we may have to go in, create a report, send the report ID, and then review what comes back. And even if this isn't vulnerable to other things such as broken object level authorization, broken function level authorization, the endpoint might return sensitive data that it shouldn't return. And really, there's no shortcut for understanding the application and going through methodically and thoroughly testing each endpoint. So now it's challenge time. There is at least one other endpoint that leaks some sensitive data. So your challenge is, of course, to find it. Make sure that you have sufficient data in the application to test. So at least a couple of users that are registered, add their vehicles, add a video, and so on. I'm not sure if I mentioned this already in a previous video, but setting up our target environment for testing is a crucial step to make sure that we don't miss out on some behavioral functionality within the application, regardless of it being intended or not. What I like to do is set up a few users and just add all of their details into my notes, such as their email address, password, ID, phone number, video name, anything really that belongs to that user, so that you can quickly identify if you're onto a Bowler vulnerability or if you find a leaky endpoint that reveals excessive information. Good luck with the challenge, and I'll see you in the next video. All right, welcome back. I hope you had a good stab at the challenge and really got to know the crappy application and all of the endpoints, because in a chapter later on where we look at chaining vulnerabilities together, you're going to have to understand how the endpoints work, what they can give you, maybe more importantly, what they can't give you. So let's go down the list, and we checked a bunch of these already, and we found that originally, which one was it? The get recent posts endpoint returned quite a lot of data and obviously was quite sensitive. And interestingly enough, it also returns the user ID as well. So for example, Adam007, his user ID is this. So what I'm going to do is I'm going to copy this, and then we're going to come down to the get post. And when I send this, it obviously sends the ID. And what I'm going to do is I'm going to go jump into Burp Suite and further test this. Send to repeater and send this. And as we can see, it actually, again, it leaks the email address and the vehicle ID if there is one, and basically leaks sensitive information. And if I put in another ID, for example, we get Adam007, so we can get the information of other users based on their ID as well. So if you found this endpoint, congratulations, good job on the challenge. And if you didn't, don't worry, make sure to update your notes, and I hope this improved your methodology and thinking a little bit. This was quite a short section, but of course, really, really important to always be on the lookout for extra information or parameters that endpoints shouldn't return. I'll see you in the next section. SSRF, which stands for Server-Side Request Forgery, is a vulnerability that allows an attacker to have a server-side application send requests on their behalf. usually to an internal resource that is not externally available to them. So let's take a quick look at an example. Here we have an appointment booking application, and in this example, we're going to make the server make requests to itself via the loopback address 127.0.0.1. The attacker, whilst in the user context, can invoke this request that gets the up-to-date list of available booking slots. The request contains the payload with the booking information request filters, such as the date range, and a legitimate request looks something like this. So to exploit this vulnerability, we simply need to intercept the request, drop in our own payload, and forward the request on. The request, instead of making a call to http API booking example.com, calls the admin page on the loopback address, and because the server trusts itself, it serves up the page without complaints. So going back to our definition, the application we are exploiting is making requests, in this case to itself, on our behalf. Of course, we could also try and access other internal resources that the server has access to, but we don't have direct access to. In the next video, we'll walk through a practical example, and then we'll give you a challenge, as always. I'll see you then. Now, for our demo this time around, we're actually going to be utilizing one of my favorite free resources, the Portswigger Academy. This is because the SSRF labs in the Academy are API-driven and freely available. It's actually a great resource to further practice the tools and techniques that we've learned on the course, so I highly recommend you check it out. For now, let's dive into a SSRF lab. All right, so here I am at Portswigger's Web Security Academy. If you want to sign up an account, or if you haven't used this before, simply go to portswigger.net, sign up a free account, and then come to the Academy at the top, and you'll find all of their labs and tutorials on here. I've already clicked access the lab, so we'll just jump straight in. And here we have a application we like to shop, and just looks like a standard shopping application, and looks like there's a my account, so username and password. Doesn't look like there's any registration functionality, so we don't get to register, unfortunately. But let me come into the conversation controlling lemon. It looks like he's having a rough time with that. So here we have some functionality called check stock, and we're going to check the stock in London, and it comes back with 911 units. And this looks like an API request because the page stayed the same, it didn't refresh, it just popped up with a little bit of extra data. So this is what we're going to check out. Now if I come over to Burp Suite, and I come down to the bottom, so we see /product/stock, and we can see our original request and the response 911. If I send this to repeater, click over, send it again, we actually get a slightly different response, which is slightly odd, but that's okay. And we can see in the request that we have this stock API equals HTTP, and it looks like a lot of encoded characters. So we can just Control-Shift-U to decode this. And I'm just going to get rid of that so that we can see things a little bit better. And we have the HTTP stock.welike2shop.net AT-AT product stock check. And the product ID is 1 and the store ID is 1. So if we go back to our lab, we know that the objective of the lab is to reach HTTP localhost/admin and to delete the user Carlos. So first of all, what we're going to do is let's change this to localhost/admin. And notice that I'm going to leave the product ID and the store ID in because there might be some kind of processing. Of course, if we have time to test, we can take these out and test fully, but there's no harm in leaving them in for now. And we get a 200 OK. And if I scroll down, it looks like we have some kind of admin panel, as we can see here. So if I just render this page quickly, let me move myself out of the way. We can see that we are indeed on the admin panel. So we know our objective is to delete the user Carlos. And if we come down, we can see this endpoint. So /admin/delete, username equals Carlos. So let's just copy this, replace this here, hit send. We get a 302 found, so we'll just follow the redirection. And we get a 401 unauthorized, but actually we still did manage to complete the lab. As you can see, we get congratulations, you solved the lab. And if we hit render, we get this congratulations message, and we get the admin interface is only available if logged in as an administrator or if requested from the loopback. So what happened here was the server made the request on our behalf. So it went to localhost/admin, delete, and deleted Carlos. But then we got a 302 back and we got forwarded to /admin. And unfortunately, because this request to /admin came from us, we don't get access to the admin panel. But the action was still carried out behind the scenes, if that makes sense. This is a really, really powerful attack. And as we've seen with the increase of APIs and the increase of things like microservices, server-side request forgery is becoming more and more common. So definitely something to look out for. And of course, now you know one of the main things to look for is URLs or partial URLs that are passed in either the URI or the body of requests, or sometimes even the headers as well. So for our challenge, I'd like you to spin up the crappy application and identify a server-side request forgery vulnerability. Now, I'm purposefully not giving you an endpoint to look at this time because we want to start getting into the process of stepping through an application methodically, identifying things that are suspicious, or finding potential indicators of a vulnerability. And since we already know the vulnerability that we're looking for, I have confidence that you can find it. This is also an opportunity to decide what tool you think is most suitable for the task at hand and start solidifying your workflow. As always, we'll walk through the challenge together in the next video. I'll see you there. All right, let's take a look at the challenge walkthrough. I hope you all got on well and found the server-side request forgery SSRF vulnerability, but if not, let's take a look and we'll walk through it together. So I'm just going to come to the crappy application and sign myself in like this. And you can see that we have the dashboard page. And this vulnerability is actually in an endpoint that we looked at previously. So it's in the contact mechanic endpoint here. So if we just click on this, we get this form. So we just need to choose a mechanic and we need to put in a problem. So wheel fell off. And then we can send the service request. And we get a success message saying the service request sent to the mechanic. And we can just click OK. Now, if we come to Burp Suites and we find the post request that was made, we can close the inspector and make this a little bit bigger. And I'm just going to move myself out of the way. There we go. You can see in the request, we actually have a mechanic API field and a URL in that field. So let's test this out. Let's take this to repeater with Control R, come over to repeater, and all I'm going to do is I'm going to test this against a website that I know will probably respond. So https://www.google.com. Now, I should say that if you're working in a production environment or you're working on bug bounty, when you're testing for things like server-side request forgery, probably it's not wise to use things like request bin or Google and other services because you might potentially leak sensitive information. But in this case, because it's just a lab, it's okay. An alternative to this is to spin up something locally and connect to that. So I'm just going to click send, and here we are. We get a response from Mechanic API, and this does indeed look like a response from Google. So if I just type in the keyword, you can see that we get the Google homepage back, and you can see this in the title here. So from this, and as in our demo, what we'd want to start thinking about is what functionality can we connect to locally or within the target environment, and how can we use server-side request forgery to get to things that we shouldn't be able to get to. And we'll talk a little bit more about that in the final section, chaining vulnerabilities. So that's it for this section. Once again, congratulations if you solved the challenge, and if not, don't forget to update your notes, and I'll see you in the next section. Welcome to the penultimate section of the course. We've covered a lot of materials so far, and I really hope that we can start to bring this all together and explore some more complex scenarios. I'm going to keep this section quite short, as it's really just a demo of stringing together things that we've found along the way, but I wanted to include it as it actually took me quite a long time to find and exploit this vulnerability when I was actively working on the crappy application. However, before we dive in, I want to talk to you about command injection. Now, we didn't specifically cover this in the course, and it's not really any different than other injection vulnerabilities such as SQL injection that we did cover. To achieve command injection, we need to find a place where our input is executed. Now, before we continue, I just want to mention that command injection can be really destructive. You might interfere with or crash your target application. So it's really important to consider the payloads you're sending, especially if you're working on a production system. A really common example of command injection that you'll see a lot in CTFs is when we have an endpoint that takes an IP address, and we'll ping that IP address and return the results. In this case, the IP we provide is directly passed into a function that can execute it as code. If there is insufficient filtering or protection, we can simply append commands. So common ways to do this would be semicolon and then add your command, or ampersand and add your command, and so on. You can take a look at any command injection cheat sheet to get an idea. And of course, it's important to keep in mind that command injection will vary from application to application, but you get the idea. So why is chaining vulnerabilities really important? Well, a lot of vulnerabilities on their own have very little impact, but as penetration testers, we often have an objective that might be something like, can we steal customer data? Or can we take over the accounts of other users? Occasionally, you'll find a critical issue that lets us achieve this objective all at once. But more often than not, you'll only find things that are just a small piece of the puzzle. Within the crappy application, there is a chain of vulnerabilities that can lead us to remote code execution. Now, this is a completely optional challenge, so if you're feeling up to it, feel free to stop the video here or after I've given a few hints and have at it. Remember that you can always make a start and come back for hints later if you're stuck. You know yourselves, so I leave the decision up to you. If you're not feeling quite up to the challenge yet, don't worry, the capstone will help you hone your methodology and should increase your confidence. Maybe then go on and treat the crappy application as more of a research project or pushing your boundaries. All right, the first hint. So pause now if you don't want to hear it, but if you do, then I suggest you check out the endpoints that deal with user videos. If you need a second hint, then let me give you the vulnerabilities in the chain. So we're looking for mass assignment, server-side request forgery, and then, of course, command injection. Good luck with the challenge, and I'll see you in the next video for the walkthrough. All right, let's do this challenge. And I'm quite excited to walk through this because there's lots of different things that we've done which kind of come together nicely. So first, let's sign up a new account. So I'm just going to come in, call it Alex, and I don't know, let's just do j@j.com because I know I haven't used that yet. And we'll just give it a random phone number and a password. All right, and then we can log in. So no vehicles found. So I'm just going to add the vehicle quickly. Whoops. Grab the VIN. And then grab the PIN code. I'm sure you've all done this many times now. And what do we get? Ah, BMW. Sigh. All right, so what we want to do is we want to come to our profile page. And then Actually, what we're going to do is let's come over to Postman first. And I'm just going to set up a quick account. And then we can add a video. Let's re-add this video file, car.mp4. And this is the request where I realized that code execution is likely possible, or we had a chance. And I don't know if you've spotted it, but take a look at these parameters. And one of these parameters actually has some code inside. So you can see here we have the conversion params, and we have the -v codec H264. So this is probably going to execute some code, some like conversion. I can't type in there, but and it's going to pass these in. And we already know from previous modules that the application might be vulnerable to mass assignments. So we might be able to upload a video or edit a video and set this parameter. And that was the first clue that I spotted that led me to the remote code execution vulnerability. So let's do that. Let's upload a video. And then upload this. Video uploaded. And then if we take a look in Web Suite, this is our video upload. And you can see, if I just move myself out of the way, you can see, again, we get this conversion params. Now, instead of uploading a new video and defining this, what I found was what we can do is we can actually come in and we can change the video name. And I want to change it to just test123 and press OK. And then we can see this put request here. And in the response, again, we see this conversion params. So I'm actually just going to right click and highlight this so that we don't lose it, because I want to keep this request. And same goes for this one. Usually when I'm working on a bunch of things, occasionally I'll highlight requests just so that I know that I need to come back and look at them more closely or carry on testing them. So we send this request, and here what I'm going to do is I'm going to just do colon, paste, and usual remote code execution is we can do something like ampersand, and this will basically say, hey, once you're done with the previous command, please run the next command. And I'm just going to do something like touch temp and RCE, something really simple. And because we're testing locally, we can simply log into the Docker container and check that this has actually worked. Or you could get it to ping you, or you could even set up a reverse shell, or you could get it to curl a website. So for example, webhook.site is quite a useful site. So you just copy in this URL here, and then any requests that come in. So I'll just show you quickly. If we manage to invoke this, it's a good way to cross server-side request forgery. We'd see the request coming in. Obviously, don't do this with production systems where there's sensitive data and things like that. You don't know what webhook.sites are doing with their data. But for this, it's totally fine. Or you can just set up your own web server and call out to that. There are a lot of different options. So find one that works for you, that's kind of reliable and that you can, play around with, and then you should be good to go. Now, the next thing we need to do is actually trigger this. So when I was looking at the functionality, I saw this share video with community. So we can just click this and we get a failed. We get a could not convert video. So if we come back to Web Suite, come down here, and we see the request here. So could not convert video ID 83. So I'm just going to highlight that, send it to the repeater, and let's just see what's happening. And This is a little bit like CTF-y here, I would say. We could probably have found this without needing the message, but it says this endpoint should be accessed only internally, and it gives us the endpoint URL as well. So if we're accessing this endpoint externally, obviously we're going to localhost 888 and this URI here. But if we're going to go to it locally, then we actually need to call HTTP crappy identity 8080, which is different to our 8888, and then call it. So it took me a little bit of time to realize that this was different and the routing was different. It wasn't the same as the external, but you know, we live and learn to look in the details. And I would say that occasionally an endpoint might be like, hey, you know, you can't reach this from where you are, or this resource isn't externally available. And again, that's kind of like a clue that maybe if we have SSRF or if we have another way to access it, then we might be able to trigger this vulnerability or at least get access to this endpoint. And if you look closely, we have this S, capital R, F. So it's actually giving us a big clue. Luckily, we already discovered the SSRF endpoint in the application. So I'm just going to copy this. And then we're going to click OK. And then we're going to go back to our trusty mechanic and test. Click OK. Come back to WebSuite. And I'm looking for a post request. Here we are. Get this. And then let's just send this to the repeater as well. And again, this highlighting is quite useful. If you're going to come back and do reporting and you're not taking very good notes as you go, that can be quite a handy thing to do. So I just send this and it says OK. And what we want to do is copy in our endpoint, click send, and the video ID parameter is missing. So we need video 83. Click send. Video conversion bash command triggered. And I wasn't actually expecting that to come back. So let me double check the endpoint. I forgot to hit send on here. So we didn't actually update the video. So we just come back, hit send, and we get this message. So all I'm going to do is copy this. Looks like base 64. Come to the decoder. Decode as base 64 and says, wow, look at you, combining mass assignment and SSRF to exploit a hidden shell injection. We're very proud. I'm glad you're proud. It's nice to have somebody who's proud of you. You won the game. Unfortunately, we don't actually allow our pentester to run arbitrary shell commands on our backend. Could be very expensive and annoying to maintain. Again, yeah, very easy to destroy a system, especially if you've got multiple students doing crazy things. So a little bit limiting there, but if you want to go ahead and get your shell, then feel free to follow the instructions and update the configuration and try it yourself. So that's it for the chain vulnerability walkthrough to RCE. And sorry, I have a kitten on my desk. I'll see you in the next video for the capstone challenge. Welcome to the final capstone challenge, and I'm really excited that you've made it this far, and I really hope you enjoyed the journey throughout this course and managed to learn some new things that you can add to your arsenal going forward. Now, this final challenge is going to be purely focused on some API endpoints, so let me give you a bit of a briefing. A company is building a web app called the Pasta Mentor. There are a number of teams working on it, and they feel like they're ready to have the backend pen tested for issues before the front-end integration takes place. The tools that you use are up to you, and you can take as long as you'd like to assess the application. The developers have provided a couple of things though. some basic documentation of the endpoints. One of them has also kindly added an application reset endpoint for testing purposes. This clears out all of the data of the application and creates some new test data within the app. We're also given a heads up that the application uses JSON, so whilst we're free to test other payload types for issues and things, we shouldn't let the content type header trip us up. Some sample data is also provided, and this is somewhat similar to a situation where you might get a bunch of exported Confluence pages or development notes. So let's take a quick look at this, and then I'll let you dive in. So here we are, and I have the API final capstone.zip in this folder. So I'm just going to right click and extract here. Give it a second to run. And then what I'm going to do is I'm going to open the terminal, cd into labs, cd into API final capstone. Close this down, and looks like we're all good to go. So sudo docker compose up. And we'll give it a second to load. And that was pretty quick. So we get MongoDB connected. So the first thing we want to do is come to the application. So http://localhost, and it's running on 3000. If you're ever unsure where it's running, if you come into labs, cd API final capstone, if we just look in the Docker Compose file, you can see that 3000 is open and routing to port 3000. So this is the web app. We obviously want to connect on port 3000. So I'll just switch my proxy off for the time being. And when we come to this, we can see that we do indeed have some basic documentation. Although, unfortunately, it doesn't give us a full set of testable payloads, but it's a very useful place to begin. Something else that we want to just make note of before we started. So as I mentioned before, we have a reset function. So we have this controls/reset. So if I just come into the application, type controls, resets. And if I can spell it right, we get the application data is reset. So if that's a little bit small for you. So this is just for testing purposes. You can use this as much or as little as you'd like. One other thing to check out is if we come to /controls, I think there is also a file called sample data as well. So you can come in here and, like I say, this kind of simulates some developer notes or some old Confluence pages or some exports, things that the developers have been working on, and maybe their personal notes and payloads. So this is a really great place to start. It gives you a sample request to get started with the application. And for these endpoints that are listed here in Swagger, you've got some test payloads as well. So I'm just going to quickly make a request to make sure everything is working. So what I'm going to do is actually, let's just split this and load up Postman. Let's just create a new collection. Rename this collection to final capstone. And then in here, add request. I'm just going to close this. And what we'll do is we will, let's see, what request do we want to do? Let's post to register. So Control C on this. Change this to post. And we want to put the full address in. Localhost 3000. Rename this to register. And in the body, we want raw data, and we want it to be JSON, because that's what we've been given here. So, whoops, I'm just going to grab this, copy and paste, and then let's just hit send. and we get a registration successful, which is great. So that's exactly what we wanted to see. And again in burp, so make sure the application is working in burp suite. Let's not update right this second. And what I'm going to do is I'm going to just switch on my proxy, hit refresh here so that I've got a request coming in. Send this to the repeater. Change the request method, which changes it to a post. I have my sample data here, and I suspect it's going to throw an error if I just send test, although let's just give this a go anyway. And the content type, so we have application xwww form. So I have actually an extension installed called content type converter. So you're welcome to go ahead and install this. So all it does is enables me to go extensions, content type converter, convert to JSON, or you can just manually change this. So for example, this to JSON like that. So it's up to you really, whatever you want to do. I'm just going to use this content type converter and then click send. Whoops, I think I undid this. So this was v1 auth register. And we get, yeah, username already exists. So of course, if we give it a unique username, hit send, we get registration successful and we get a session ID back. Okay, great. So the application is working. Everything is set up. Feel free to use Burp Suite or wfuzz or Postman or any tool you want, really. This is your assessment. Make the most of it. Try and find some critical issues that you'd be very happy to put at the top of a report and put some recommendations into. Good luck, and I'll see you in the next video for the walkthrough. All right, welcome back. Let's take a look at this application, and I'm going to walk you through kind of how I would approach this and things that I would look out for and how I would kind of like follow my intuition to find vulnerabilities. And of course, everybody's methodology is a little different, but I quite enjoy manual testing and being thorough and stepping through the application step by step. Other people go for a more automated approach with lots of recon and then dive into things separately. And both are valid approaches. So do what's best for you and let's dive in. So first step, I'm going to come over to Postman. So we have this new collection here. I'm just going to delete this. Boop. So it's out of the way. And then we already have our register endpoint, and it looks like we can register a new user and we get a session token. So what I'm going to do is usually I use Obsidian for notes, but I run Obsidian on my host machine, and just because of the way the camera is set up and capturing the VM, I'm just going to keep some notes in Mousepad. So in fact, I might just keep it on another monitor, another workspace, sorry, because otherwise it's going to get very, very full on this one over here. So I'm just going to come in and just write test. So this is our login credentials and our session ID. So just keeping some notes so that we can come back to them. And the next endpoint down is v1 auth login. So let's come back to Postman. And I'm just going to come in and add request. And let's call this login. And I'm just going to come here, copy this, paste. And then we'll come here. And it looks like it takes the same username and password as before. So let's just go body, raw, JSON, and send. And it looks like we need to change the request method. Let's try that again. And we get login successful, so we probably get a new session ID now that we've logged in a separate time. Yeah, it looks kind of similar, which is interesting, but somewhat different towards the end. And what I'm going to do is actually send this request again. So come over to send. And then grab this. It looks like the request is different again. So at this point, it looks like the session token that we're getting back, the session ID here, is quite short and looks like it's base 64 encoded. So we can just come to BubSuite decoder, decode as base 64. Yeah, and it looks like it's just our username and then some text or some random string afterwards. So we've got a lowercase, uppercase, and a number in there. This doesn't look very strong. So let's do a little bit of analysis on this. And what I want to do is come into repeater, and we're just going to change this to login. Check that this works, so we get our login success, and then we're going to right click and send to sequencer. And then what we want to do is configure this so it knows where our session ID is. Click OK. And then since it's base 64, again, I want to come to the analysis options and base 64 decode before analyzing. And then we'll just start the live capture. This won't take too long because it's a local instance. And while it's doing that, what we'll do is we can come back and test another endpoint. So we've got this v1 auth check. Actually, since we're harvesting IDs, we probably are going to be unsuccessful, because hopefully the IDs don't just last forever, although that's something we should check for. Does an old session token still work even after we get a new one, or is it invalidated? So I'm just going to come over to Postman, add request, and just call this auth check. Localhost 3000. Grab the payload. Raw JSON and put that in. We'll just send it, and we probably again need to change this to post, as I always forget. And then with the invalid session ID of test, of course, it's just going to come back unauthorized, but this endpoint is working, so that's useful to know. So the live capture is about halfway done, so I'll just wait for this to finish. All right, and looks like it's finished, so we can just hit analyze now. And the overall result, so the overall quality of randomness within the sample is estimated to be poor at a significance level of 1%, and the amount of effective entropy is estimated to be 30 bits. So if we come to the character level analysis, we can see that indeed we have our username, and this is highly predictable, and then we have a lot of random characters afterwards as well. So this is quite weak, and I think if you wanted to, you could probably brute force this. You could write a quick Python script that takes an input, generates 6 random characters, and then spits out a word list, and then you might be able to demonstrate this attack. And if you have some skeptical developers, or if you want to show this off in your reports, then I would definitely recommend doing this exercise, writing the script, and finding a session and taking it over. But for now, I think, given this summary, this is probably enough for reporting on in most cases. So next up, we have V1 recipes. So we can search for a recipe. So let's come to here. And interesting that, so get V1 recipe, get V1 recipe. So it has a parameter. So I'm just going to copy this, and then I'm going to pull this into Beb Suite, come back to my repeater. Is it recipes or recipe? I can't remember. We can right click, change the request method to get. That's recipes. Send this and see what comes back. And whoops. And we get an OK with no data coming back. So likely there are not any entries. So let's just leave this blank. And we do get some data back. So it looks like this is working. And we get the Alfredo and the spaghetti with meat sauce. And something that is interesting here is we need to pay attention to the intended behavior of the application. And this says is private true. So this is probably a little bit of a leaky API endpoint. And we can see the chef here is the admin. So this is probably the creator. And it's also useful to notice that we have some IDs here as well. So this is kind of some interesting points that we want to just take away from this endpoint and consider or think about. So I'm just going to add this one into my Postman collection. And then we can just check that it works and we're good to go. All right, so next up we have post recipes. So interesting that in the developer notes that they gave us, we have a post V1 recipes. But in the Swagger notes, we don't have a post recipes. We have a put, which looks like it will update a recipe, but maybe they've missed this out in the documentation. And don't be surprised if this happens. This happens quite a lot where information is out of date or missing. And it basically signals to us that we need to do a little bit of fuzzing. We need to do a little bit of digging on our own. So let's go ahead and take this one. So I'm just going to come back into Postman. Oops. Add request. And then let's call this create recipe. It's going to be a post. And luckily, they actually gave us some data to work with. So I'm just going to copy this, the pasta carbonara, drop this into the body, raw, JSON. Let's do this. And I suspect we need our session ID as well. So let's grab that. We need to check what our most recent session ID is because we've been fuzzing. So let's just do the login. Send. Got this session ID. Let's just replace these. Hit send. And we get recipe created successfully. Which is great. Okay. So our next endpoint is puts. So we need a recipe ID. So this is a good time to grab this ID and store it for later. And is there any other information we want to grab out of here? No, I think we're all good. So let's create a new request. And this one is update recipe. And then we want the ID. So let's give this a try. And actually, I think because we're updating, we probably need some data. So let's grab the data that they've provided us. And we'll also put in our session ID as well. Recipe successfully updated. And interesting, something that also I've just spotted, which I don't think was in, yeah, it wasn't in the recipe before. You see we have this original undefined. And here in the dev notes, we have a link to original recipes. So this is probably something that we want to look at anytime a payload or a URL is being asked for or passed in. We want to think about server-side request forgery. So we'll just think about this and put it in our notes to come back to later. So I'm just going to copy and paste this. And what I want to do now is just grab this, come to the search recipes, hit send. Actually, I didn't even need the ID. I just wanted to make sure that our new recipe was indeed here, and it looks like it's been added correctly. So we're all good, basically. Always good to double check that it's doing what it says it's meant to be doing. So next up, let's keep going through these endpoints and then we'll dive a little bit deeper. So we can add a request. V1 data title. So what is the description of this? Get a genius pasta pun. Nice. So get pun. And then, so V1 data slash title. Let's just send this. This too shall pasta. We'll send it again. Pasta la vista. Okay. So it seems like it gives us a random title each time, which is cool. And let's add the next request. So we have titles. So I think it's looks like it's basically the same, but get all the puns. Yeah, indeed, we're correct. So it just returns all of them, which is great. All right, and the next one we have data internal action. So server maintenance only accessible locally. So again, this is kind of another red flag saying, hey, we should probably be checking for server-side request forgery. And if we compare this to the notes, we have v1 data admin recipes. It is here. Sorry, I missed over this and skipped to the next one. And I was thinking that there was a discrepancy, but we're all good. So let's look at this one first. V1 data admin recipes. Add request. So let's add this. We get unauthorized. And I think looks like we need the session. Still unauthorized. Let's do one last check with a valid session ID. And we're still unauthorized. So we might want to think about how can we create a invalid session ID for the admin user if we know what the admin user username is, because the first part of the session is the username from what we can tell. And then the second part is random characters. So this might be something that we want to try or something that we want to come back to. All right, so next up we have the v1 data internal action. And if we look at the sample request, we have /uptime. So let's take a look at that. Interesting though, this is a variable, so it might be that there's more actions available. So this means, again, we probably want to think about fuzzing. So we add request. Uptime, and then we're going to call this internal uptime. And we get, sorry, for security, this endpoint is only accessible locally. So yeah, seems like we're going to need to find a way around that and request it from another place. So generally speaking, this is kind of how I approach an application. I'll test each endpoint individually, get a feel for what it does, and then kind of form some thoughts or some ideas of where to go next, and then go next. Now, this is a little bit different to like a vulnerability assessment situation where you'll have a checklist or a number of things that you want to test. This approach is more like looking for critical vulnerabilities, but of course, in the real world, when you're attacking an application, you want to go through, you need to test the authentication, authorization, and everything else. But hopefully this gives you an idea of how I like to step through an application and really get to understand it, to find vulnerabilities that are not obvious to begin with, but usually quite critical later on. A couple of things that I've thought about so far is that there seems to be no brute force protection, so collecting the session tokens was very easy. We haven't seen any cross-site request forgery tokens at all, and the session token looks very weak. So these are all findings that I would definitely put into my report so far. So the next thing I want to test is this internal endpoint, because I'm not convinced that this is the only endpoint that might be available, and there might be other internal endpoints that are not properly configured, and we might be able to get to some things. So I'm just going to grab this URL. In fact, we can just make a quick request to it, and we get the sorry message. And then we can come to Burp Suite proxy, HTTP history, and send this to the intruder. And I'm just going to add the selection here, come to payloads, and we'll just use, I think derb should be good. And then we'll use the big one since we're working locally, should be fairly fast. Nothing too fancy at this point. All right, so we have this 401 and we get the response saying, sorry, and this was our original request, so we're expecting that. And if we filter by our status codes or order by the status codes, we also see a user's endpoint with 401, but unfortunately, we get the same message back. So it does look like we're going to have to go hunting for SSRF to be able to get to this. But uptime and users both sound quite dangerous. Uptime sounding like it returns the response of a command that's getting the uptime of the server. So we might think about command injection here. And the users, this might give us some sensitive information as well. So definitely worth looking at. So I'm going to come back to Postman, and we're going to come to this here, and you can see it says get. I think if we save this, it should, yeah, there we go. Yeah, updates. It doesn't save the post type automatically. So let's just go through and save these all quickly. And what I want to do is we have this recipe and we have this link to original recipe. So let's just test this quickly. https://www.google.com, and let's see what happens. So we get recipe successfully updated. So it was okay with it. And then we can't see the recipe ID, but we know that we can search for all the recipes. And it doesn't look like it comes back with anything interesting. So I think we need to find an endpoint that is making use of this link rather than just returning it. So let's go back and see if we missed anything. All right, sorry about that. So basically, I spent about 30 minutes trying to figure out what was going on. It seems like the old Swagger file had cached to my browser history and it wasn't displaying the new one. But obviously, you doing this lab, you'll have the up-to-date and working code. So we did miss out an endpoint as we were going through. And this one is, I'm just going to add it in here. Oops. Add request, and then we're going to call it get recipe. And this is going to be v1 recipes and then an ID. And as you can see, I've already tested that. So here, what I'm going to do is I'm going to grab, oops, where's my mouse pad gone? Ah, it's changed windows. The recipe ID from here, come back, paste this in, and send this away. And as you can see, it comes back with our pasta carbonara. And this is the one that we changed our original link to. And you can see that what it does is it goes out to this link and then calls this the original recipe. So the intended functionality here is to link to other recipes. So if you had a pasta carbonara recipe that was a variation of another one, you could then put the old one or the original one or the link to the original one here. But in this case, we easily get server-side request forgery. So let's test this against our uptime endpoint. So I'm just going to come here, copy this, come back to puts, update recipe, paste this in here, hit send, and then come back to get recipe. And we get a uptime back, which is great. So now in our report that we can say that we can access internal services via the application, which is a critical finding. And something that's even more exciting is if we go back and recall that we found the user's endpoints. If you recall, we actually fuzzed the internal endpoints and found users. And if we add this in here, click send, recipe successfully updated, and then come back and get the recipe, we can list the users in the application. So this is quite interesting to see. And you can see a couple of users that looks like they were added. So test and then test2, which we added. And there is an admin user as well, although the password is not hashed. And I suspect this is because this is added by the reset script, and the reset script probably just inserts it directly into the database rather than going through the registration endpoint. Now, there's something else that's really interesting about this finding, even though this is obviously a critical issue and something that should be at the very front of our reports. We also see this user level parameter. So if we think back to one of our previous labs, when we create a user, we were able to pass in extra parameter values to set things for that user object. So let's give this a try. Let's create a new user and see whether instead of what seems to be the default user level user, we can actually make it admin. And in turn, hopefully that will let us access the admin endpoints. So I'll come back to register. And I'm going to create a user. Let's just create one called Alex. And I think it was user level, if I recall. Hit send, and we get a registration successful. And what we want to do is we want to copy this session ID. So let's just add this to our notes. And we can probably verify this actually just by going to the get recipe, clicking send again and seeing what's happened. And we can indeed see that we have the username Alex and we have the user level admin, which is quite cool. And when we do the get recipes, here we had unauthorized. We can paste this in and we do indeed list all of the recipes. And so that's it for the major vulnerabilities within this application. Now, there are other smaller issues to uncover, of course. So things like the privacy tag doesn't work. So if a recipe is set to private, it seems like anybody can still view it. And there may be other medium and low findings to add to our report as well. But I think going over these two critical vulnerabilities, these are the main things that we really want to emphasize in our reports. So we just have one last video to go before we close up for the course, and I'll see you there. So we just have one final video left in the course, and it's been an absolute pleasure so far to be able to share my experience and my passion with you. So that's it. And once again, I just want to say how much I appreciate you going through this course and sticking with it to the end. It really means the world to me that I can share my passion with application security with you. Now, don't be a stranger. Feel free to reach out and connect on LinkedIn or drop into the TCM Discord. And if you ever bump into me at a conference or a meetup, don't hesitate to say hello. Good luck with everything in the future. And until next time, all the best.